Okay, welcome back. Let us move on to one more concept now, that is called as on-off cycle timers. On-off cycle timers. That means whenever it is necessary to have a kind of output, something like this. Let us say I have an input signal somewhere starting like this. So this is my input signal, and you have two timers. You make use of two timers here. So one, it is, say this is the input signal. Okay, let us not take that, it is confusing. Yeah, we will have one timer operating for a particular time duration, something like this, and the other timer. So this is the timing signal. The other timer is operating only when the first timer is not operating, something like this. And accordingly, you may have the output either with respect to the sequence of the first timer or with respect to the sequence of the second timer, or something like this, right? So now this is my output. Let us say that this is my timer T1 and this is my timer T2 and this is my input signal, something like this. So in order to have this kind of timing diagram, generally in the examination also you may be given some timing diagrams based on which you will have to draw the ladder diagram, and accordingly you will have to draw the write the instructions also, right? So now if you want to realize this kind of the output, right? So how would you draw the ladder diagram? So now let us say that I have got an input signal, something like this, and please look here, after having drawn the input, I will have to activate the first timer, but before that please note here, let me call this as I in here, input. This is my contacts with respect to T2, and here I will have T1 with suitable the value of K. Let us say that K I have taken it to be 10 seconds, right? So anything you can take depending upon what exactly is asked there, right? So now in the second rung, your T1 contacts come here, then it is going to activate your T2. Again for T2, let me take K equal to 10 only. Then now your output, if you look at the output here, so this output will follow the output of your timer T1, as you can see here. So as long as the output follows the timer T1, now the third rung, whatever you have here, that should include your output and the contacts of the timer T1. So now what exactly happens, you can understand in this particular ladder diagram, right? So here both the timers, that is T1 as well as T2, they are designed in such a way that the output is switched on for 5 seconds and again the output is switched off for 5 seconds. So switching on the output for 5 seconds is being taken care of by the timer T1, as you can see there, and switching off of the output for 5 seconds or 10 seconds, in this example for 10 seconds, it is being taken care of by T2. So you can understand here, I have the input signal here, this is my input signal. So needless to mention again that your timer T1 will be activated for 10 seconds, right? So after the input signal has come, the timer T1 is activated for 10 seconds. Now you should be able to understand why there is a delay between this point and the timer getting activated. So now this gap, whatever we are having, this also amounts for 10 seconds, right? So now the timer T1 is activated for 10 seconds here, you can see here from this, right? So the T1 contacts will come in the second rung, as you can see here. So once the T1 contacts come in the second rung, so that again activates your timer T2, okay, so for 10 seconds. So once the timer T2 gets activated for 10 seconds, after the 10-second time is elapsed here, you can see here, after the 10-second time is elapsed, so this contacts, that is T2 contact here, it gets opened now because it's a normally closed switch. So it gets opened. So when it gets opened, it will deactivate your timer T1. So that is the reason why whenever the timer T2 activates, your T1 is getting deactivated, and whenever your T1 is activated for every 10 seconds, since the contacts of T1 has come in series with your output, right? So the output will also follow the same occurrence pattern as compared to that of T1. So now here in this case, this is for 10 seconds and the remaining period from to here, this is for 10 seconds. So this pattern, it will keep repeating and you will get the on-off cycle timer, right? So depending upon one timer's operation, the output can be controlled to exist for that particular period of time, and for the remaining period of time, the other timer will come into action, which will make only the first timer to get deactivated. It doesn't affect the output, please remember here. It will make the first timer to get deactivated, and accordingly you will have the flip-flop, that is the output remaining high for a preset period and low for the preset period. The repetition of this, it keeps happening, right? So now you just think of how best you can have this kind of applications in the industrial process control, right? So if at all you want to have the sequential on and off of certain outputs based on the required time duration, so this kind of situation can be had. So this is called as on-off cycle timers. So now if at all you want to have the time duration different as per your requirement, right, you can definitely set the value of K different for T1 as well as T2, and accordingly you may have the occurrence of this output at a different duty cycle rather than 50% what we are seeing right now, right? So that kind of applications also we can have. This is referred to as on-off cycle timers, okay? And now in the beginning we have seen the on delay timer, off delay timer, as well as the pulse timers, if you remember correctly, right? So I have also shown you how exactly you are going to get the working of the on delay timer. So whatever we have been seeing so far, those are all the on delay timers only. What do you mean by off delay timer? What do you mean by pulse timer? All those things we have seen, right? So in some situations it may not be possible for us to have the off delay timer inherently available to us. That means though there are three different categories of the timers, that is the on delay timer, off delay timer and the pulse timer, not necessary that every time these three versions are available distinctly. That means whenever you have got an on delay timer, you should be in a position to convert it to an off delay timer. That means given the on delay timer, how do you generate an off delay timer, right? So that is what is our next discussion now. So here in the next discussion, what I will write here is as the off delay timer. Off delay timer. You know what is the meaning of off delay timer? We have already seen it earlier. Now let us try to see how exactly I can realize a off delay timer here. You can see here I have an input signal as usual, then one more signal from your timer coming in series, then I have from these two I have one timer coil as well as one output coil. Here what I do is bring the output back as a latch. So now this is my timer T, this is my input IP, this is my output coils coming as the input switches, this is my output and this is my timer coil. Please try to see what exactly is happening here with the help of this diagram. So now here in this particular case, my timer is a conventional timer, and using a conventional timer I wish to have an off delay timer. So what exactly happens here? Let us say that your input is momentarily closed. So that is quite understandable by virtue of the parallel contact with respect to the output which appears across the input, right? So whenever you just use a momentary pulse to or a push button switch kind of thing, right? Input, right? So your output gets activated the moment you press the input. The output gets activated because here this is a normally closed switch. So this is a switch which I have activated this way. The output gets activated. So once the output gets activated, though you remove the input signal, since the output coil is associated in parallel with the input signal, the output will continue to exist, right? So now the same output will make the same input will make the timer coil also to get activated. So once the timer coil is activated, depending upon the time period, let us say that it is a K, phi or something like that, right? After certain time, depending upon the value of K, so the timer will get reset. Once the timer gets reset, your output is also going to get reset. So this is what is going to happen here. So now you will have the nature of the output something like this. It is like this. Now you can see here, this is the input and this is your output, and here you have the timer. The moment the timer stops here, output is also going to stop here. So this is what is the nature of the output that you are going to get here. So this is the timer coil. So again, if at all you want to activate the input in your next cycle, you will have to repeat the procedure, right? So this is called as the off delay timer. This is called as the off delay timer as per as the conventional timers are concerned. How do you get the operation? Or you can also consider it to be output which exists or which appears after a certain delay, or after the input pulse has ceased, right? After the input pulse has ceased. In that way, you can interpret this off delay timer, right? So then you have one more that is called as the pulse timer, right? So the same example can also be considered as pulse timer, but only thing is that in your pulse timer, so I just come to the next. Pulse timer, right? So in the pulse timer you will have the output in the form of a pulse here. So now how do you realize a pulse timer? Using your conventional timer, you can an input signal as usual, I in, then this signal is going to activate your timer, and here your timer coils or the timer coil is coming in parallel with the output with a normally closed configuration. You can see here, this is my output, this is my timer, this is my timer coil, this is my input. Now you please try to interpret this, how exactly the output can be obtained here. So as long as the input is present there, your timer is going to get activated, right? So the timer, you can just, I will draw the waveform here or the timing diagram. One second. Okay. So now you can see here, I start my input from somewhere here. The input is continuously present, right? So you can see here the timer contacts. It could be or it could be open here depending upon the time. So now it's going to be your output. This is the output depending upon the type of the signal here, right? So now what exactly happens, can you understand here? As we know, the pulse timers are going to give you the output for a certain interval of time, that is the predetermined interval of time. So whenever some input is initiated, right? So now you can see here, in this particular case, whenever the input exists, right? So there are two outputs, as you can see, since there are two parallel branches which we have taken here. Whenever the input exists, one is your timer is going to get activated, and another, since the coil is the normally closed coil, the output is also going to get activated, right? So it is very simple now. So the timer at this instant, that is at this instant, right, your output is also going to get activated, and now depending upon the time setting here, so the timer going to get closed if it is a normally open contact here, or it is not, it is going to get opened if it is a normally closed switch, right, or normally closed. I have taken here now. So now once the elapse, I mean the preset time period is elapsed, right, so this contact now gets opened and you are going to get a pulse here, the output pulse, something like this. So this is another kind of operation what you can have using the timer. So of course all these things we have seen as a general structure earlier. Let me go to that. Here, so we have already seen this, the on delay timer, the off delay timer, pulse timer, but this is as per their IEC 1131.1 standards are concerned. But if at all you have some timer like this,
off delay timer or on delay timer, that's what we have to see, and that's we have seen now with the help of these three diagrams. Okay. So now with the help of these things, let us quickly look into a couple of simple examples based on the timer operations, and we will see how exactly these simple examples can be realized. Let me just write a problem statement here. I request all of you to note this. Open a valve V 15 seconds after a switch S1 is on